Now we're going to talk about adding the two together. So let's start off with one. Well, let me ask you this. Guys, if I asked you to do 2x plus 3y, could you add those together? No, because they're not, what's the word? Like terms, right? Because one has an x and one has a y. They're not like terms. In the same sort of idea, we can only add or subtract like radicals. And we would do it the same way. So let's pretend for a minute, say it was 2x plus 3x. What's that really? 5x, right? You just add those coefficients. So what do you think this would be if I asked you to do 2 root 7 plus 3 root 7? What's that going to be?
6 root 7.
What'd you say, Steve?
5 root 7.
5 root 7. Yeah, because we're adding. So I want to just add those coefficients. So 2 plus 3 gets me the 5. Guys, notice how the square root of 7 didn't change. It just carried throughout the problem. So no matter how weird it looks, say I gave you this, I don't know, negative 14 square root of xyz, and I wanted you to minus 6 square root of xyz. Are these like radicals? Yeah, because what is under the radical is exactly the same. So now I'm just going to do the math with the numbers in front. So what is negative 14 minus 6? Negative 20. And then I just keep that square root xyz. Okay? So, big star, you can multiply or divide any radicals. They don't have to be the same. We haven't done any division yet, but we will in a minute. Any radicals. But you can only add or subtract like radicals. That's a big deal. And the same goes, I don't know if you remember, but with fractions. You can multiply any two fractions together. You don't need common denominators. But remember when you go to add or subtract them, it's always a little bit tougher because you have to have those common denominators. Okay? Now, here's one. I don't want you to get messed up on this one. Let's try this. What if I asked you to add together 4 times the square root of 3, and then I wanted you to add to that, let's see, the square root of 12. Could you add these two together?
If you simplify the second one.
Uh-huh. Right now, it doesn't look like they're like radicals because you have a root 3 and a root 12. So that's clearly not the same. But Eric just pointed out, this can be simplified. Right? Can I break this up into what?
4 and a 3.
Square root of 4, square root of 3. So that first one stays the same, right? Nothing happened with that. But now what's this become?
2 square root of 3.
2 square root of 3. So when I put them together, I really get
6 square root of 3.
6 square root of 3 as my final answer. So don't just, at first glance, just assume, well, I can't do it because they're not the same. You have to check if anyone can be simplified. Because if they can, you may end up with 2 that can be added. Does that make sense? Yeah, we're all right? Okay, so let's kind of put together, let's do a multiplication and an addition one. What if I asked you to let's do the square root of 2 times, how about 4 plus the square root of, let's do 6. How would you handle this problem?
Would you distribute?
Yes, I'm going to distribute the number out in front to everything that's in here. So what's the square root of 2 times 4?
4 square root of 2.
4 square root of 2. And then square root of 2 times square root of 6 would get me
Square root of 12.
square root of 12. Perfect. Notice he's in the house, he's not. So when I multiply the two of them, I just write them next to each other. He's in the house, he is in the house, so they both go in the house. It's a very simple concept as long as you keep that straight. If you multiply two numbers not in the house, they stay out of the house. If they're both in, they both go in. Now, is this a final answer?
No, you have to simplify the second one.
Yes, that one simplifies again. Square root of 4, square root of 3. So I really have 4 square root of 2 plus, what's this?
2 square root of 3.
2 square root of 3. And now can I add those two together?
No.
No, these are not like terms. There's nothing else for me to simplify. So that whole thing would be my final answer. Does that make sense? Okay.